Hello. So this time we are going to work on a few things that I believe will turn out to be relatively simple. And first, we're going to fix a few things about the macros that I believe are going to cause trouble if we don't fix them. Um, anyway, this is going to be in util.h. So the I put a semicolon at the end of while, which is not correct because this means that if you use this inside of like an if branch or something, and it's the only statement, it's going to cause problems. So like you couldn't do if foo grow array by else something else, because this would just turn into if foo and then the actual statement like do while and then two semicolons, which means that else is going to be a syntax error. And so this is easy to fix, so I'm just going to fix it now. And we're going to delete that and delete that. And that should be all. Yes, and there's another macro down here too that I correctly formatted. Oh, but this one, bug, is not correctly formatted. So let's remove that semicolon. And I'll make sure everything is working all right. Yep, that was fine. So now I will commit this, and I will say remove trailing semicolons from macro definitions. Okay, great. So number one is partially done. Remove trailing semicolon. Now the other thing I don't like is that I use the word free here for free array, and free is also used in the C library function free, that word. And in that context, it means that it's releasing something off of the heap, releasing a heap pointer. And free array is not really releasing a heap pointer, uh, at least not explicitly. It's removing something that's on the stack. And so what I want to do is I want to use a different word for free here. And I've chosen to go for destroy. And the reason I'm making a big deal of this is because I will probably be making more macros like this in the future, and I want to make sure that the names stay consistent, or at least I can use the names consistently and not cause confusion in the future. So now I can look for usages of the macro, and it was called free. The old name was free array, and I used it twice. And check kanji db order line 345. And there, destroy array. And then I use it in make map line 11 here. All right. And by the way, does that match the number of times I initialized an array? Let me see, memset. Let's see, which of these is an array initialization? I don't think I initialized any arrays in this manner with memset. 388 memset. And here it is in 0 memset. This is not an array. So we also have it in line 406. 406. There we go. Used unused kanji keys. This is not an array. And util.h line 37. That's obviously not an array. Well, it's part of an array's backing array, a resizable array's backing array. So that doesn't count. So I'm just double checking here. I just want to make sure that I released all the arrays I initialized. So we had two uses of free array or destroy array, and we have 1, 2, 3 times. So this is another way we could initialize an array with 0. And that is in free kanji keys line 8. That looks like that is an array. and key mapping array, that's also an array, but line stats I know is not an array. So we're fine here. Now let's run make. All right. So now I'm going to commit this. And I'm going to write a crappy commit message now, but I'll write a better one later. So this is going to be what? Rename free array to destroy array. So let's show this commit again. Yep, that looks fine. All right. Oops, I want to go to the tasks list. New sort. And here we go. So I finished the cleaning up the macros. Now add an init macro. So yeah, the thing is I had this deal where I didn't really know where I was initializing arrays because sometimes it was memset and sometimes it was with those that like curly brace 0. And I don't know if I like that very much. I don't know if I like that there's 2 ways to initialize it. But on second thought, this may be something I want to do later, but at this point I don't really feel like it is going to be a huge win to create an init macro. And I'm not totally sure that I'm going to need it later. I'm not totally sure that it's going to help maintainability in the long term. So I'll hold off on it for now, having considered it. But at this point, I feel like adding it is just kind of an over-engineering thing, and maybe not worth it, or it's just a wash. So let's just forget about this one for now. Okay, and next, did I commit? Okay, I committed that. So there's also an unused struct I noticed when I was reading the code, kanji data. So I don't remember what I wanted to use that for, but I never did use it, this struct right here. And so I'll just delete that. And I'll make sure everything's still working. Okay, good. And by the way, I'm curious if making things in parallel with multiple threads is gonna work. Looks like it worked, but I can't tell if it actually made it faster. Oh, I have to clean, maybe make clean and make with 8 threads. Seems like it's not making it any faster. Or at least it's not really making a big difference. Alright, so the build is obviously not very complicated at this point. Now, so we build, so I'll just say that remove unused struct declaration. Alright, there we go. That's my new commit. And char to key index, I noticed there's a function which only is used inside of the romazi.c module. So what char to key index does is it converts a character on the keyboard from ASCII into its keyboard like index, or the like positional index on the keyboard that we've adopted for this input system. So now if we grep for char to key index here, we'll see that it's actually, let me make this a little bit easier, it's only used in romazi.c and h. So we can remove the declaration here, and then char to key index is here. Now there's a bit of a problem, by the way, because I also noticed there's a bug here. So I have this static like array, right? And in here, that this function, the static array, is actually being used. and also initialized if it's not. And the thing is, the way I check to see if it's initialized or not is kind of bonkers, because it's looking at index 0, and we're never going to use the index 0, like is is not correct. It's like this is the null byte, which is not going to actually be used at all. And so this is always going to return false, which means we're never actually caching the char index. And maybe to prove that, because we're always going to reinitialize it, because the little check we do always evaluates to false. So let's try here. I'm going to print out something if it's already been initialized. So fprintf standard error initializing. All right. And I bet if we make, we're going to see that a whole lot come out. And yeah, see, it comes out a whole lot. Now, what we could do is just say like char to key index 0 equals ff. That's a bit of a hack, but we know that we're never going to use 0, and so we're just going to use it as a indicator that it was not found, or that we're going to use this array index, which we'll never use, as an indicator that's initialized. 0 char to key index map. Okay, try again. All right, and that time initializing only was printed out 1, 2 times, which is good. But I don't really like the fact. So the thing is, there's also no way to know when it is. So the thing is, there is a key with index 0. And so there's another problem, because this is going to be initialized to have 0 in all indexes. And so that means that if someone calls char to key index, someone calls char to key index with something that that's not actually in the map, it's going to have the same value as if we called it with the number 1, which has the value of 0. See up here, 1 is the first item in the reverse map. So what I believe we want to do is actually change this around so that we initialize to some other value other than 0. That way we can kind of tell when there's an error. So I'm going to say memset char to key index map, set it to, instead of 0, we'll set it to ff, or all bits on, and we will see. Size of char to key index map. Sorry, my mind was wandering a little bit there. So yeah, that should work. I guess we don't really need to debug that. We know it's pretty obvious that this is going to be fine. Let's make. Okay, that worked. Now, char to key index can sometimes return ff, but let's take one step at a time. We want this to be static. We don't really need it outside of this module, so we're making it static. Make. All right. Okay. Now we can commit it, and what are we going to say? Make char to key index map static to romazi.c, and fix a bug where we reinitialize the array unnecessarily. All right. So we are almost done with this part. So there's another problem which I kind of touched upon a few videos ago, or at least alluded to, that this key index to char map is really only important for kanji keys, and my reasoning being that when we're generating the kanji mapping, we actually care about ergonomics. And so we really only care about keys that are used in the kanji. But the dash itself is used only in kana. And so I don't believe that we really need this in the map, in this map, and I want to remove the dash and see if things still work all right. So what we can do is we can just remove it here, because we're not, we're not like, we don't really want to loop over the keys in the context of kana mapping generation. We want to do it only in the context of kanji generating. So now that's probably mappable char count. So this mappable char count is no longer important, or at least rather it's no longer correct. So let's try this. Do we use key index to char map also outside of this module? Key index to char map. And it's used in last rank contained. Okay, anyway, let's build this and see if it works. No. Free kanji keys count does not work. Segmentation fault. Okay, so let's see. Let's run it manually. Free kanji keys count. What is the name of the command? No. It's free kanji keys, maybe, I guess. Free kanji keys. Seg fault. Okay. So we're going to go to, where is here? Here it's implemented. Get free kanji codes is probably what is crashing. Printf. Okay. So yes, it does not finish get free kanji codes. And let me just make sure that this is what we think it is. Yes, it prints started but not finished, so that's where it's crashing. So let's go into romazi.h, or rather, yeah, get free kanji keys. Get free kanji codes here is what we want to look at. So we're going to go to the C file, get free kanji codes. All right. So kanji key count, get free kanji keys. So maybe it's failing in get free kanji keys. Let's see. Started but not finished. New sort. Free kanji keys. Let's make sure I read that right. Okay. So it's failing in get free kanji keys. And here, romazi nr, mark used. So probably mark used is char key index. So yeah, this is going to return FF, and that's this first key off thing is returning something that's outside of the array. I wonder if there's anything I need to explain here that is easy, that would help understand what's going on. But get free kanji keys, what get free kanji keys does is it shows the keys that are available for use as kanji keys, or a code, because some of the 2-character codes are used for kana and the rest used for kanji. So the purpose of this is to return the ones that are useful for kanji and are free to use. And we're not using the dash, and so I think it's okay that we remove that. I still think it's okay. We're not using the dash for kanji at all. So we should be able to just ignore that and mark used. So mark used is used in the context of get free kanji keys only. So let's see. First key off. Yes. Okay, and so this first key, let's see, this structure we're populating used bitmap. This is a bitmap where each bit corresponds to a two character input code. And so if the code that we are marking as used and reserved for Kana is 2 or more, then the process of marking it as used is relatively simple. If because we are how do you say, we are, because we only have to set one bit in the map. And by the way, the use bitmap is actually a char array, so each bit I'm talking about, each logical bit is actually a byte, which we're just treating as a single binary like switch. And so if it is 2 or more, then we just have to set one byte in the map. And otherwise, if it's just one, then we have to set all of the bytes in the map which correspond to the key code, the input codes which start with that character. And the problem here is that this first key off could be FF. And so we want to say if first key off FF, then we don't actually want to mark it used. We can just return. And the kind of sneaky thing is that we can assume the second character is going to resolve properly, because in our particular case, the FF is like the FF only corresponds to the dash, and the dash is used in as only the first character. It's used as a singleton code where the dash is just a single input code and there's nothing after it. And so we don't have to worry about the second character in the input code not resolving to a key. So that's a bit sneaky, but we test what we do, and so I'm okay with this being a bit half-baked, because if there's a problem later, we'll know about it. Okay, so this didn't work. And did I delete the printf debugging things? So let's add it back. Start. Okay, we start. Oh, look, we have started. Where do I print started again? Get free kanji keys. Oh, this is get free kanji keys count, which we don't actually call. So started. I never deleted it. So started, and this one is crashing. So, char to key index, ASCII to upper, mappable char count. So there's something else. Oh, because this is why, because we're multiplying it by mappable char count, so this never actually gets, this never actually compares as true, because we're multiplying it first. So what we want to do is we want to move the comparison here. Then we can multiply it later. First key off. Okay. Let's try again. That worked. Let me delete the printf stuff because we no longer have a seg fault. Let me see what we actually changed so far. We removed the dash and hyphen and mappable char count. So this is simply kanji key count times 2. Maybe we just want to define that as kanji key count times 2. That will be easier to this will be a little bit more self-consistent. So I'll call it kanji key count times 2. All right. Anyway, mappable char count. So now this is a bit half-baked. This kind of equals FF, and I don't really like the way that FF is used as the indicator that it's not used, or that the mapping doesn't resolve, because it seems arbitrary. If we're returning a size t, then why does FF mean unused? I would expect like all of the bits to be set in order to indicate unused. Maybe we can have it return a signed size. Now we're over 80 characters in this line. That's okay. First key off. -1. All right. So we're going to go back to, let's see, where were we? So now we want to change the use of it, or rather, so yes, we're going to change kanji, what's it called? Char to key index. And so here, char to key index map. Okay, so we kind of want to intercept the return value somehow, and then set it to the negative value, right? To indicate that it's not. So we basically want to transform FF into, size t's f. Maybe we can just change this to return int or char, like signed char. Signed char. That can be signed char, right? And so then when we convert it from -1, then it'll just be converted from -1 to -1 of the types automatically. It'll just kind of automatically expand to -1, right? So then this should work, right? Yes. Okay, because this is -1, this returns -1, and then from here and from here on these two lines, it will automatically cast it up to a bigger -1. And so there, I'm pretty happy about that. So what do we do here? Let's make a commit. We're going to say that we so remove dash from char map, and I'm going to rewrite these so they're better, these messages. Right now I write it just so I don't forget to fix it later. Char to key index, and dash return -1 from char to key index when it is not found, and also do not reinitialize. Oh wait, do I reinitialize it now? I fixed the reinitialization problem in the last commit, didn't I? So here, yeah, remove dash from char map, and there. Handle this in the call site, or at the call site. Now, there's something I actually just kind of thought. So how many times are we calling this function? We're calling it only twice, here and here, and it's returning twice. This feels like kind of a, I don't know if this is like a, yeah, this just seems a little bit like unnecessarily complicated. So my thought is that really I could just initialize it explicitly in this function, and then after it's initialized, we can just read the array directly. But then if there gets more callers to this, it's like gonna start to get messy. I guess it's fine as it is. All right. So new sort tab. All right. So good. I'm really glad. Excuse me. I'm really glad that we actually figured this. We're able to remove that dash from that map, because the whole fact that this was 40 and this was 82 was bugging me. So now we want to refactor line stats into a reusable module, and so this is going to be the actual. I believe this will be the more interesting part of the video. And I'm going to take a quick break to gather my thoughts. And okay, I've taken the break, and the line stats logic is all in this module right now, and this module. So line stats is basically what we want to factor out. Now currently this has two components. This structure, this has stuff which is kind of like global, which is, for example, what's global? Offset to target. No, not that. These three, for example, these are global and these indicate options. And last char rank, I believe, is a global. Last char rank. No. So in any case, at least these three are what I would call global, and these then there are ones that apply separately to each line. So E, for instance, indicates the kanji that are used on that line. And just so you know what line I'm talking about, source, and we go to new sort, last rank contained, and so if we look at this, each line is what I'm talking about when I talk about line stats. And so there's a few fields in there which are separate for each line, but just get overwritten every single for every single line before its output. And in order to make this more reusable, I could either allow the caller to kind of get the lines individually and not store them all in memory at once, or I can just put every line separately in the struct and just store it all in memory at one time. And I think the latter, while it uses more memory, is simpler, and really the amount of memory used is very limited. And so I'm going to go that route of just kind of using of just expanding this so that every single line is stored separately and at the same time. Let me reopen my console or my shell session, and so the first task in this is to figure out what part is global and what part is not. So I'm going to open the same file in two columns, and we're going to rename this. We're going to call it, well, we're going to have the global one, and we'll call this kanji layout summary. Or maybe it's kanji distribution. Yeah. I think I like kanji distribution better, because distribution is much more specific than the word summary. And so let's see. So these three are going to be the main thing, like the outer the global stuff, but I don't know if they make sense to put them in the reusable section. Like hide kanji, I don't know if that's more like something that's local to this module. And sort each line by radical and stroke order. Okay, stroke count. So that is okay to put in this structure, because that affects how the structure is populated. And hide kanji is not. And I was interrupted there for a second. So we're back, and we are currently trying to put things, separate things into the global and per line categories. And so this hide kanji doesn't really belong here. It belongs in like we can just make a global variable, or show per line kanji count also needs to be separate. It also needs to be out of here. So okay, and this is so I'll just say these are command flag command flags, and so we will change these to access the global stuff. Hide kanji and show per line kanji count. Show per line kanji count. Okay. So those flags are specific to this command exactly and don't really belong in the reusable section of the module. So now we can continue to keep this line stats line struct, because we're going to have a array in here, struct line stats lines, and we will say, now do we want to make this into a resizable array so we can keep track of the count more easily? I don't know. Lines, and it is going to be kanji key count. Right. That's how many we have. And by the time we're done populating it, it's going to be completely full. So yeah, then we'll accept for those lines which correspond to vowels in kana. A, I, E, O, U, A, I, U, E, O is the Japanese order. And yeah, so those are going to be empty. And I'm not totally sure how that's going to work, but probably there'll be some flag inside which we can check, or some implicit value which we can check to make sure is like, you know, if it's 0, then we know that it's not used. If it's 1, then we know that it's used. Like total chars, that's probably what we want. Total, or this is a global value. Get top keys. Excuse me, total chars. So yeah, this is a global value. So we're gonna, and target rank is also a global value. So this is the summary that we print at the end, right? So total chars, target rank, and total rank, and yeah, total rank. Okay. Excuse me. So these are global. Total chars total. All right. Kanji distribution. And total rank. Total rank is a weird value. It's like the last rank of the character for each line. I don't really know if we want that value. Like I said before, it's not really it's not really very informative. And we use the total rank to calculate the average rank of each line. And that's what we actually show. Now, last char rank. Yeah, this is like per line. All right. Last char rank. Oh, we keep it there because it's per line. K and R. And top key is per line. Offset to target is per line. Overall offset, we'll call this cumulative offset. So what this is last rank contained. So I went over the meaning of all these values before, but this this last number, is the cumulative offset from the target rank. So this line covers a certain rank range from 1 to some number around 1,000 or 1,200. And because it like allows you to input those range of ranks out of the kanji that this line is supposed to cover, that this first key is supposed to cover. And so it covers a certain range of ranks starting from 1 and ending at 1,000 or so. And the that either includes, it doesn't include all the kanji that it ought to, or it includes too many according to what the target rank is. And so that is this value, the line specific, insufficiency or like error or margin. And then this last number is the cumulative value for each, when you add it up. And so we'll store the cumulative value per line as well. All right, so we don't need this. And so last char rank, and this is per line. Yes, and offset to target, cumulative offset, offset to target, ENR, and yes, so this now seems to be correct. Kanji distribution, but now we have to use the kanji distribution properly. Right. Line stats. So let's go to the place where it's kind of all started. Struct kanji distribution. All right. So we pass this here because it contains some of the flags. And distribution. Kanji distribution. All right. That looks good. Of course, now we're only using this to pass one flag, which feels kind of funny. But we may add more flags later, so let's just leave it as it is. And so down, so here. And we're gonna have line stats still, but it's gonna like struct line stats. We'll start this off at the first line stats, right? And we'll just increment it as we go on in the function. And what did I call this? I called it lines. Let's call it line stats. I think that's less confusing, actually, to use like similar names or reuse words, at least in this context. Line stats, get top keys. I guess that means that it's not going to compile in C++ because it doesn't like distinguish between struct and non-struct. Because in C++ this could be written as this. And so now that's kind of hard to parse. But anyway, I don't want to use C++, so that's fine. Get top keys, line stats. And so when do we increment line stats? So the thing is, we're going to have to pass this line stats around now. It's going to have to be passed around explicitly. Let's just build and see what errors we get, and we can start fixing the errors. That's kind of a good place to start, I feel. Okay, so line 95. So we have get top keys, line stats. Okay, good. So I guess we need to pass the kanji distribution now. KD total chars. All right. And then get top keys, we call it here kanji. Oh, we don't need to pass line stats anymore. Kanji distribution, because this one populates every single line, right? So, all right. So where do we actually set line stats? We kanji count. So this is where we're setting k for each line. Okay, I'm a little confused. So k, get top keys. So k here we're treating as a global value. And here we had it as per line. So I think at this point, yeah, this is no longer an array. This is kind of like this is in line. So top key, and now I think that we can just inline this struct right here. Okay, because it's just stored once for every single line. Key ch and available. So we'll call this number of available codes in this line. Count. All right. First key. Character of the first key for codes in this line. All right. Okay, so this is better. Now here we're going to say this is now kd dash line stats and knr plus plus. So this was never actually a very useful. Oh, here, unused kk count. Okay. So we do probably want the size t line stats nr here. I think that would be helpful after all, because we do use it here. So we'll say kanji distribution dash line stats nr. Okay. And oh, this is not the right name. KD. And so this is now going to be KD dash line stats KD dash line stats nr dot available. Okay. So this is getting hard to read. So I'll just store a pointer to line stats. So it's like we did, what did we call it? S. What have we been calling it? Stats, line stats. S equals KD dash line stats nr. No, line stats KD dash line stats nr. Okay. We don't no longer have to increment it here, and so we have to increment it after we check if we use this line or not. So continue. Okay, unused. Continue. Then we set the pointer here, and s dash key character, and here we do delete dot s dash available. Ooh, it fits on one line. I like it when that happens. Okay, I think this is correct. Let's make again. Okay, I think there are fewer errors that time. Field line has incomplete type. Oh. Stats. Rename sort each line by red, so 105. Okay. Now this is okay, so it looks like there were no errors in this function, so that's good. Off to a good start. So end line. So we're gonna have to pass kanji distribution here. And I guess kanji distribution could be a global. No, it really can't because it's gonna be allocated like by another module now. So, but could it just be a singleton? Do we really have to pass it around all this, like all over the place? Perhaps not. Maybe we can just make this a singleton. Kanji distribution. I don't know. I mean, it's very likely we're only going to have one of these for the entire process, no matter what we do. Yeah, maybe we should just do that. So let's just call this kanji distribution. Void. And so kd, kanji distribution. Now the problem though is that now we have to use a long name whenever we use it. Distribution. Maybe we can kind of split the difference, call it kanji dist. Dist. Kanji dist. Dist. Okay. All right. And kanji distribution and line. Okay, now where do we use it here? Let's look for kanji distribution because we no longer have to refer to this type anymore, so we should be able to just remove it. Let's see, kanji distribution, dist, kanji dist. This is no longer needed. Get top keys. Kanji distribution. And we're going to have to make it static. But the thing is, if it's static, how are we going to refer to it from outside the module? Because we're going to put it in some other module, and it can't be static there. So I'm not sure how I like that anymore. Maybe we really do have to make it a non-singleton. Kanji distribution. Yeah, this is fine. It's really annoying how like you can't make these linguistic decisions up front. You have to like change it later. But I'm pretty sure that we do need to have at this point we do need to have a like struct. Okay. So now back to fixing these errors. Line 75, we fixed that one. Line 105 has no member named. Sort each line by radical. Okay, so now this is a global. Kanji distribution. Oh, no. This is in kanji distribution. And so, all right, we finished that, fixed that error. Overall offset 116. So this is now kd-cumulative offset. And really, we're going to have to remove these print statements from outside of the, like, separate them from the stats gathering eventually. So let's see here. You know, it might be easier to fix the errors from the bottom because that way I don't have to scroll up every time I run the compiler. Last string contained. line stats. 303 is actually the error where it is. Print stats summary. So this needs to be kanji distribution. Distribution KD. All right. KD dash line stats NR is a new name. And this should really be XF printout. There we go. And all right, now KD and target rank, total characters. All right, let's try again. All right, now we can go to line 304, and this is now kanji distribution. Is that what we called it? Yeah. And then line, the end line. End line has too few arguments. Okay. I'm starting to regret the name for the variable kanji distribution because it's going to appear a lot in this function. Let's just call it KD distribution. KD line stats. Okay. 303 end line. So this now needs KD as well. Let's make end line. KD and line stats. Line stats. It says it's in the wrong type, the wrong argument type. Line stats by argument struct line stats. It's not a pointer. 3 line stats. Oh, because I still have this dumb thing. I didn't change the type here. That's why. Okay, that probably cut the error count down quite a bit because that type was wrong, and so it was just really off. Line stats K. Available line stats dash K. So this is now kanji distribution dash line stats. Current top key. Line stat. Oh no. We need the current line. Line stats dash. What did we call it? Available. I think available is now in line, right? So it's like this. Available. Yes, it's inside of line stats. So we remove one, and then line stats equals resorted ranking. Line stats dash E is entry. So this is just the number of, this is just the characters in that line, isn't it? Yeah. So here we're adding characters to the line, and it's still going to be in line stats, but now it's going to be something else. It's E. Okay, it's still called E. So that maybe that statement doesn't need to change. Line stats dash E NR plus plus, and okay, line stats dash last char rank. Yeah, that's per line information. Let's just make and see where the next error is. 295. Line stats dash K. Current top key. What is K? What is K? What was K? I forgot. That'll teach me to use short names, because we removed K, and now it is going to be, I think it was like available. This is what available in key CH was, I guess. No, maybe not. Kanji entry. cutoff kanji count. Yeah, so this is going to be now available. K was the top key structure, which we've now inlined. And so we've got current top key, current top key. Okay, so now when we add, so current top key used to be the, I guess used to be the like index of the line, and now it's not going to be that anymore. It's going to be more like, okay, so instead of current top key, we actually want the NR field, line stats NR. So we'll say KD dash line stats NR equals -1. Line stats, maybe this needs to be signed size. Line stats NR. No, I actually don't think we're going to need this signed thing in the long run. I think this is going to be a artifact of refactoring. So let's just say it's 0. But it's going to be initialized as 0 for us, right? So maybe we don't need that. Top key or current top key. So what we'll do is we'll just instead of that we'll initialize this to null, right? And that will indicate that we're not started yet. Line stats. Oops. Line stats, target rank. And last char rank. Line stats. So instead of current top key equals 0, it will be line stats is null. Current top key is less than. Now what was this for? Current top key. Available. Okay. Current top key is -1. That means not line stats, right? Cutoff K. So current top key equals, this will be now kanji distribution dash line stats, KD dash line stats NR plus plus. Line stats NR. Oh, but we're already incrementing line stats NR over here. So we better not do that. So we'll say no. What we'll do is we will just increment line stats, not line stats. And here we'll set it to line stats. We'll initialize it to 0. KD dash line stats. And here we'll just increment line stats. All right. So here we don't want to do anything. And here line stats dash key character. Okay. Good. This is actually looking a little bit better than it was before. So end line, we don't really want to end line here. We want to end it only if line stats is valid. And in end line, we no longer have to skip it kind of hackily like that. So, okay, this is looking pretty good. I'm getting happier about this. So 289 is, where's the next error? 289. resorted dash ranking. The error is line stats has no member named target rank, because that's now a global. So kanji distribution, line stats, that's off, that's target, line stats, that's available. Line stats, that's available. So here we're continuing, and so current top key. Okay. So I'm worried that I'm going to get into an infinite loop here, because if it's not available, this means no more no more no more characters are available to, like, no more codes are available to use in this line. Then we're going to continue. We're going to go up here, and then we're going to check if line stats is not null. So line stats is null, or all of these are true, and none of those are going to be true. So line stats that's available is this looks like it's going to turn into an infinite loop. Oh no, because we're going to keep on incrementing I here, and then it will eventually finish. And then we'll eventually get down to here, and it will end the last line. So I think that's fine then, I suppose. I'm a little, but then why does that work? Because it seems like available will get down to 0 for every single line, wouldn't it? Available. That's available. Oh, but no, we're changing line stats here. So current top key. So okay, so let's leave that for now. I'm guessing it's all going to work out. So instead of this clause right here, we want to change current top. We want to make sure that line stat still has can still be used. So we'll want to say line stats is not equal to now this means it's the last one, right? So line stats is not equal to kd dash line stats line stats nr kd line stats nr -1. Okay, that checks whether we're at the end, we're at the last line in the output. Cutoff kanji dot k is not equal to radso sort key cutoff kanji. So this is a struct which we have, which hasn't changed, and k is now current top key. Oh, I guess we still need this current top key index, don't we? If we're using it to index into k, this separate array. Cutoff kanji. What the hell is cutoff kanji? I guess maybe this should now be part of the field. Kanji. This should be part of line stats, I suppose. Key count. And then kanji entry. Yeah, because this stores the cutoff for every single one. Yeah, I rather think that cutoff kanji should be part of this struct, part of line stats now. So let's do that. Line stats. Line stats should be part. So. Key count. But key count is the same thing as ENR, right? And it looks like we're key count. I'm wondering what I just deleted. So top key used to have a key count value, or no, cutoff kanji used to have a key count value, which is a number of items there. Kanji entry, and then it has the, so key count is more like K and R. It's the number of items, right? So, And I think we already store the cutoff kanji, don't we, for each line? Cutoff kanji, line stats. This has a character first key, ENR. Because we set it here. I guess, no, maybe not. We set it to 1 at one point. Here. We set cutoff to 1. And, okay. And cutoff kanji dot k dash c. All right. So I think what we want is we kind of want this to, now we maybe not need this at all. Cutoff kanji. Read user cutoff kanji. This is getting a bit more involved than I thought, but maybe the light is at the end of the tunnel. Cutoff kanji count. Read last rank contain parse args. Cutoff kanji. Resorted R. K. So I believe this needs to now be line stats dash cutoff. What did we call it again? Line stats, struct line stats, cutoff, ENR. So yeah, construct kanji entry cutoff. Lowest or first kanji in sorting in Radso order, or that is less than or equal to all kanji in this line. All right, cutoff. So this doesn't really make any sense as a separate value. As cutoff. All right, resorted dash. Stats. So now cutoff. Cutoff used to be. Okay, so now do we want to check the cutoff of this line or the previous line? And I guess it's the next, the next line. Line stats plus 1. Cutoff is less than resorted. All right, that looks good. Now cutoff equals 1. Okay, so here we're starting a new line. We've already added 1. So we don't store cutoff here anymore. We store it elsewhere. And down here we're going to do line stats dash cutoff. All right. Okay. Now we just need to make sure that we set the cutoff properly. Cutoff kanji. Yeah, we don't want that anymore. Cutoff kanji. Read user kanji cutoff. Line stats dash kr. Okay. Cutoff kanji count. Okay. So this is the number of cutoff kanji that the user manually specified. So we want to delete this. Cutoff kanji count. We don't need that anymore. And we don't need line stats itself, but we do need kanji distribution here. I'm wondering what's the best way to sort these or to split the line. Res. Okay, res, then okay, cutoff kanji count. We don't need line stats anymore, but we do need kanji distribution. Cutoff kanji count. It's a bit noisy outside. The garbage truck is coming by. Cutoff kanji count. We need that. Cutoff kanji. We don't need that. All right. Cutoff kanji count is not equal to kd-knr minus 1. This is actually going to be line stats nr. And this is actually starting to read a lot better. kd-line stats nr. All right. Cutoff kanji count. Okay. So now we're going to search for cutoff kanji. We still pass the cutoff kanji. What is that? Cutoff kanji is not what the user passed themselves. Oh, so this value, this first argument is what we're setting it to, is the value we set to the result. So kd-line stats I dash dot cutoff. I believe we called it cutoff, or we called it cutoff kanji in the struct. We called it cutoff. Okay, let's go back. Cutoff kanji. kd line stats dot cutoff. So I don't like having to use this long name. So let's just cutoff. All right. Let's save that. Now cutoff, and we're searching in there, and we're looking for cutoff kanji. So so this B search is a macro I made, which does a binary search, and so it's going to look in this array over this number of items, kanji db and kanji db nr, and so it looks at the whole kanji database, and it uses Unicode ordering. Oh wait, that doesn't seem right. That doesn't seem right. Oh, because I guess kanji database is sorted by Unicode ordering eventually. So, or after the startup, but not when we actually writing the data. Not when we actually save the code. In the code, it appears in our custom ordering. So string compare cutoff to cutoff kanji raw, and okay, then equals cutoff. Now here we actually save the cutoff value, but cutoff. Okay, we didn't find a equals no. All right, and here we can look for. We're checking to make sure that the kanji is valid used as a cutoff type or a cutoff character. And because if cutoff type is 0, that means it's basically equal to the previous character in the sorting order. So this is looking better, but we also want to set the kd-line stats 0 dot cutoff equal to 1. This is the very first kanji character in the sorting order. Okay, and it's okay to hard code that. That's like never going to change. So we have now let's see if we can make this and get. All right, 260 is the next error to fix. So line stats dash k, kanji cutoff k, line stats dot available. Rank coverage reset. 260. Number name K. Okay. So sorry, I'm hesitating. Available is this. So available is something that we kind of decrement as time goes on, which I don't really like. But anyway, that's how it is for now. Target rank, rank coverage reset. Okay, 290, 260, 259. No member name, target rank. KD dash target rank. Okay, that's now a global value. Now 256 line stats dash KNR. I guess it's ENR now. Line stats. Do we still have that NR for the number of characters? I guess we do. Cutoff kanji count is less than line stats. Oh no, this is line stats NR. Line stats NR, and this is kanji distribution. Cutoff kanji count. Okay. Target rank. So now we go to the next error, 256. Let me clear the highlighting. 256 KD dash line stats NR. Okay, already fixed that one. And next error is 248 KD cutoff kanji raw cutoff kanji 248. So going to be to read user cutoff kanji count. Somehow the argument types got mixed up. So we're passing KD, cutoff kanji count, and cutoff kanji raw. Cutoff kanji count is in number of items in cutoff kanji raw. And that's what the user passed in exactly. Okay. So cutoff kanji count. Okay. Let's build again. Now we have line 263, cutoff kanji.k. No. Now we want to do, okay, this is where we're setting. So this is in KD-line stats cutoff kanji count, I guess. That's the index cutoff kanji count. Where are we? Oh, we're incrementing cutoff kanji count here, so that looks correct. So then dot cutoff. And okay. Okay. Let's build again. 269. First key, then rank. Okay, so here we're sorting the kanji so that it's easier to process. And so we're using the cutoff kanji, but we don't really want to use cutoff kanji anymore. We want to use kanji distribution. That's going to have the cutoff information in it. And first key, then rank. Kanji distribution, KD. Okay. First key. Okay, here we do KD. Okay, so what this function does is it sorts the lines first by the key, which means the first key in the code. First, it sorts the kanji by two criteria. The most important criteria is the key of the key of the first key in the code, and the next is by the rank. In other words, how commonly it's used. So first key now takes kanji distribution, construct kanji distribution KD. All right. I guess I wanted to use one line per argument. KD cutoff kanji dash key count. what is key count? What was key count? So now we want to search for the cutoff character, and that's going to be line stats nr. Okay. And oh, is this a binary search that we can refactor to use that macro? No, I think not. This is kind of like a specialized binary search that we can't really use a utility for. So, all right. And here we got to do kd dash line stats mid dot cut off. All right. Let's build again. Okay, now the next error, k at 269. And first rank distribution. This argument, first argument type is incorrect. Pointer type. Q sort. KD. First rank, then LT. Struct kanji distribution. Expected a const, but it was a non-const. Okay. Expected a const, but it was non-const. But that should be fine. 69. First rank, then LT. Construct kanji distribution. KD. Struct kanji distribution. So I don't see what's wrong. First key, then rank less than. So this is not a const. This is very interesting and expected. Argument 1. I don't know why it wants a const here, and it can't just take the non-constant, make it const. That's kind of surprising. But this function has gotten much cleaner after all this work, and we're not even done. How many more errors do we have? Kind of a lot. So let's see here. KD, read user cutoff kanji. First key, 269. First key, then rank less than. Let's look at the macro and see what's wrong. 84. If LT is the last argument. LT is the comparator. And we are passing KD. Yeah, I don't really see what's wrong here. Must be some weird corner case about passing consts. Read user cutoff kanji. Strange. Let's skip that error for now. Maybe once we fix some other errors, it's going to be kind of obvious what's going on. So line stats dash target rank equals resorted. Target rank is actually in KD. All right. And next error is on line 168. That's a jump. And this is line stats I dot cutoff. What's wrong with that? Line 168, assignment from incompatible pointer types, cutoff. Oh, this needs to be a kanji entry. Struct kanji entry. Right. Okay. Now, there we go. Let's try again. Okay, line 269 still has an error there. We'll ignore that for now. And total chars, line stats total chars. What is total chars again? It's a global thing. Total characters. I guess just do KD. right? Next error is on line 153. Here, string comparison, -c. Okay, and I think I'm going to take a break for a few minutes, or maybe all day, depending on depending on my schedule, and so we'll stop here. Okay, so I'm back, and I might not have that much time, but let's see how much farther we can get with cleaning up these errors. So I noticed that actually kanji distribution was used before it was declared. So I'm going to move this declaration up. All right. That looks better. Let me just make this again. Okay. Oh, it looked like that last error was resolved, the mystery one. Maybe the compiler error was incorrect. Maybe the compiler was reporting the error incorrectly, even though there really was an error. So okay, we don't have quite as much problems anymore, it seems. Yeah, we only have like 3 pages or 4 pages of errors. So 147. Now, it seems like I am assigning a cutoff. I'm assigning this character as this is a string, obviously, but cutoff is a kanji entry. And I wonder, do I really need the kanji entry? Perhaps I don't need the kanji entry in the cutoff field. I just need the string. Line stats cutoff. So where am I using it? Okay, I'm using it here and here. So here, okay. Because we're setting it to ichi here. Okay. So the problem is that we kind of need to do this search for the first cutoff, which is implicit. The first cutoff is the kanji numeral for 1, but that's not given by the user explicitly. And so what we probably want to do is say that cutoff here. Okay, cutoff kanji count. So we're searching for something. We're searching for cutoff kanji raw. Right? So what we could do is just do this. Just search for 1. Cutoff. For line stats I.cutoff. Let's move this up here because we're going to need it outside of the loop. So we will say that the string we're looking for is ichi. So cutoff equals that. So we're going to, instead of this one, we are going to say that. Okay. So we're looking for ichi in the list, and so here we're going to we're going to make sure that we're going to die if there's an error, right? We're going to say then bug. Bug is a macro we have here. Error. Ga kanji database ni de mitsukarimasen deshita. So ichi was not found in the kanji database. And otherwise, we're going to say kd-line stats 0 dot cutoff equals cutoff. We can actually move this into the loop here. I. Okay. And that solves the off by one error of like 0 being of us putting that in the, it had an off by one error if you were paying attention, where this I was writing it to the wrong spot. So now it's writing in the correct spot because it starts off at 0. So let's make again. Oh, let's fix some more errors because it looks like we don't really need to. Okay, this is LD because it's now a size T type, and 119 total rank, KD dash total rank, and last char rank. Okay, try again. All right, we're getting closer. Last char rank equals, let's see, last char rank, last char rank. So this is now line stats. We need it in line stats, don't we? So 113 overall offset. So this is now cumulative offset. Cumulative offset. It has cumulative offset. So this is actually going to be S dash cumulative offset equals S minus 1 dash cumulative offset plus the current offset. And yeah, this is kind of weird that we're implicitly looking at the item before S in the array, but let's just get this working before we kind of go overboard with the code cleanliness. Then S is KD line stats. Okay, I have to dereference this, don't I? All right. Okay, we actually compiled. That's good. Check kanji database order test quiet failed. Okay, check kanji database order is the actual command. Looks like that worked. Okay. So what failed? Because the consistency check is passing. Last rank contained test. Oh, segmentation fault. Last rank contained test. Sort last rank contained is what. All right. So we have an error here. Probably in that place where I did -1. That's really abominable. So this should actually be, So if S is KD dash line stats, then we want to say S dash cumulative offset equals S dash offset to target because we're starting at 0. Otherwise, we can, that was wrong. Otherwise, we can do this. And then maybe we should use a tertiary operator, or ternary operator rather. Let's see. Yeah. All right. Then offset to target. Well, we're always going to use offset to target, so we'll put this here, and then we'll say plus this, and if it's true, then we say 0. Otherwise, actually, no, I don't like, let's not use it. Let's say, first we initialize it there, and if it is not the first one, then we actually will offset it. Offset plus equals. Okay. There we go. That should work. Okay, segmentation fault still. Last rank contained test. Typical Kogiri kanji test. So that's when we're actually setting the characters. We're actually specifying the cutoff characters manually. So let's say when we don't specify the cutoff manually, does it actually run? No, it does not. So let's fix this fact that it's not actually running without crashing when we run with no arguments, because that should work. Last rank contained. So let's see here. Parse. So here, get top keys. Let's say okay, it gets to here, so it runs top keys, and it seems to be fine. And now let's see if it gets to down here. Yes, it does. So now let's see, does it get down to here? No. Okay, so it's seg faulting in this area here, and cutoff kanji count is 0 because we're not specifying any kanji manually. So we're going down here, we're sorting resorted, and that should not cause any problems. And down here, kanji stat line stats nr. So we're going to loop over everything except for the last item in cutoff in the line stats. We're looping over every line stats except for the last one. And so then we let's see, rank coverage reset. I don't remember exactly what that does. Find best cutoff is, let's see, line stats. Cutoff equals resorted carry. So maybe this is out of range. So let's use 1, let's use 4 here, and 5 here, and 6 here. All right. Okay, it's printing 2, but not anything else. So it must be getting into here. So it's not even getting down here. So let's see if we can get to 2.5. 2.5. Okay, it gets to 2.5. How about 2.75? Yes. So it's printing 2.75 but not 4. So it's crashing in here. And so it's giving the target rank and the number of characters available in the line. Rank coverage reset. What does that do? It's not in this module. Git grep rank coverage reset. Rank coverage test. It's in rank coverage.h.c. Coverage.c. Okay. Rank coverage reset. It's freeing ranks. So the rest are just assignments to non-heap values. So it must be this that's crashing. And ranks is static. And ranks set to null. So ranks is getting corrupt somehow. It's static, so it's initialized to null. Rank set. Rank. Setting ranks. Oh, well, it actually could be in the like dereferencing of these values, KD and line stats. So line stats is initialized to null. So that may be what the problem is. Cutoff kanji count. KD dash line stats. Cutoff kanji count. dot available. Okay. Okay. So we are calling key capacity. So start at 0, rank coverage reset. So I'm wondering why we're not getting doing the very last. We're doing nr minus 1, but not going all the way to nr. That seems wrong. Well, we are finding the best cutoff point, so we don't need to find the best cutoff for the last line. That doesn't seem right. Oh, maybe we need to start at, yeah, cutoff kanji count. So what I think we need to do is we need to start cutoff kanji count at kanji count equals 1. And 0 needs to be 0 needs to be set to 1 again. So let's see, where did we actually set 1? Set it here. So let's do kanji entry first kanji in radso, right? And so this is always going to return ichi, obviously. And then kanji cutoff, kind of return cutoff. Okay. First kanji in radso, but there we go. And cutoff. So here. So here we're going to say cutoff equals first kanji in radso. Right. Okay. Cutoff. So okay. Okay. I think we don't need these printfs anymore. So cutoff kanji count equals 1. And so that means we're basically saying kd dash line stats 0 equals first kanji in radso. All right. Dot cutoff. Okay. And here, may as well put this in the for loop, because that's what everyone expects. All right. The kids are yelling in the background. I don't know if that's audible, but okay. So now we're back in error correction mode. 7. Line stats I dot cutoff. First kanji in radso. Const static okay, cut off. So cutoff is not a kanji entry. It should be 267. Kanji first cutoff 28. This is confusing. So it doesn't tell me what types is what the expected and actual types are, which is making this confusing. Return from incompatible pointer type. Okay, 142. Go. Struct kanji static const. Oh, here. There we go. Okay. That's better. Cut off construct. Okay. So we're getting closer. New sort, last rank. Let's see if this usage case passes. Okay, good. This actually passes, but it's the one where we're parsing the cutoff kanji from the user where we are crashing. Last rank contained test. typical kugiri kanji test. Okay. So we need to fix that. And cutoff kanji count is okay. Cutoff kanji count. Read user cutoff kanji. Cutoff kanji. Okay, so I'm guessing that it's crashing in this function. Okay. Let's see. 1, 2, 3, 4. Oh, so it's not crashing in this function. Test. So is this test line printed before the test finishes or after? Edit last rank contained test. So typical kugiri kanji test is like the second test. Start test. Edit test util. Start test. Start test. So prints it at the start of the test. Okay. Prints at the start of the test. So this means that this function is fine. Alright. Use a cutoff kanji. So maybe it is failing later on. SCF1. Let's see if it gets down here. ASDF1. No. Let's see if it gets here. Okay, now it's getting farther. ASDF1. It's getting to 1, but then it's crashing. Well, it's getting to 1, but before it was not actually getting there. Right. Now it's, yes, it is getting there. I must have made a mistake somewhere. Typical kugiri kanji test. Typical kugiri. Oh, so it's not crashing where I thought it was anymore. It's crashing down in rank coverage test first key. All right. Edit rank dot coverage test first key. What is doing first key? Okay, so this is where it's sorting something. It's sorting add. Okay, yeah, this is kind of a this is going to be complicated to remember and to explain once I remember it. Rank coverage test. Rank coverage reset. Last rank contain test. Now wait a second. It's not crashing. Where's the segmentation fault? It says last rank contain test failed. And then there's a segmentation fault. Last rank contain test segmentation fault. Last rank contain test. Typical kugiri kanji test. It seems like it's still failing in typical kugiri kanji key test. Last rank contain test did have a segmentation fault. So typical kugiri kanji test. Last rank contained .c. Okay. Let's see if we get here. Last string contain test, the end. It's not getting there. I don't see it ever printed out at all. It's never printed out? Oh, am I running this with multiple threads? Yeah, I've always been running it with multiple threads. That's why when I tried multiple threads earlier in the video, it didn't change the behavior. Because now it's much slower. Typical cookie kanji test. Okay, so now this is better. This is a better way to debug because it's consistent. It's deterministic output. Typical cookie kanji test is printf standard error at the end. Let's see here. EF10. Make -j1. 10. It's a cookie kanji test. Okay. Let's say zero, not enough args, 0, 0, 10. Where's it actually failing? So it gets to 10, but not to the end. Okay, it's getting noisy, so I'm gonna take a break, and I'll finish this some other time, maybe tonight or tomorrow. Okay, I'm back, and I just thought about this without turning on the recording, and I think I figured out. Well, I figured out at least one problem. I don't know if it's the only problem causing seg faults, but here I'm trying to print cutoff. The pointer to a kanji entry rather than a pointer to a string. So I'm missing this -c here. So let's see what happens if I do this. Ren. Oh, no, that didn't do it. Let's try and print. So I wonder if I can go ahead and print standard out here so I can actually see a little bit about what's going on. It's 0 and 10. Xprintf. No, I didn't see anything. Okay. We're gonna have to do some more checkpoints here. Here and see %ld. Let's print the index of the for loop, and we'll do it again down here. And where else do we want to do it? Maybe down here. Okay. Okay, so it's getting to 3694. Why is it not adding anything here? That doesn't look right. 11, 12, oh, because it's doing the same one. Okay, so here it's doing 13 over and over and over again. Then it gets to 11, 12, and 13, and then it has a seg fault. So that means we're essentially switching to the next line, and then in this if loop right here, and then we are going down and we are trying to change something here. And so maybe this is because it's the last key. Perhaps that's what's going on. Because it looks like once you get to 3000, it's basically that's basically the end of the kanji codes. But the thing is, it should have capacity for up to 40, which is more capacity than it needs. It only needs like 34, so it's not an off by one mistake. So maybe this part where it's incrementing ENR too much. Oops. Let's try this. Let's see if it fails on that line. 15. Gets all the way to 15. 5. All right, let's add another checkpoint. And going to 10.5. Okay, getting to 10.5 and then seg fault. So let's also print out where we are, what line stats line we're actually on. It is, oh, are we not actually incrementing line stats NR? That could explain a lot. No, we're incrementing it here. But then, yeah, so we can't really use it as the number of, as a checkpoint or as a marker for like a cursor. So because it's always going to be the same value. Oh, but we're not using it like that, are we? 10.5 and okay, 3695. And then it's, let's see, is it getting down here? No, made a mistake. So I forgot to finish this. Line stats minus the first line stats. That will give us our index. Get to 31. So we're almost at the end, but it should have enough capacity to read 31. So it must be failing on something else. So we're getting close to the actual problem, I believe, because we only have 4 lines where this seg fault could be possibly happening. And I'm sorry I'm not a better debugger user, although I really probably should be using it. But let's see what else could be wrong. Maybe line stats NR is not what we expect it to be. So let's print out kd-line stats NR. And I think that's a long, so 31, 33. Line stats NR is 33. Okay. And what is the resorted NR? What is the maximum value for I? Let's figure that out. I is resorted. Okay. Let's try that. It's 4003. So it's not to the end yet. Okay, so line stats is not very high. It's not at the end. It's not at the beginning. Oh, cutoff must not be set yet? I guess cutoff in line stats is not actually being set. So printf standard error sdf 10.6 and I think this is how we want to do it. Line stats +1 dash cut off. Okay. This is looks like a real 10.5. Okay. So it's not even printing 10.6. So that must mean that line stats +1 is not giving us a valid value. As strange as that seems. Or it's going to cut off. But cutoff is, we're just reading it as an integer here. So that couldn't possibly be the problem. Line stats. Now line stats cutoff is a pointer. Now line stats +1 is just so line I must line stats +1 I guess is not what I think it is. Now it should just be going to the next item in memory, and and the +1 should just cause it to go to like the the one that's right after it in memory, because the +1 is essentially going to mean plus the size of the element, not just +1 byte. So what is this third number? Why has it changed so suddenly so large? 0, 31, 31. Okay, the second number is line stats NR. How did that get so screwed up? 10.50. How did line stats NR get so wrong? That's kind of strange. So if I run it again, is it going to be kind of non-deterministic? Yeah, it's like random. Okay, so this is probably what the actual problem is. Well, I can't say that because it's actually not printing out this line, this second line. But line stats NR should not be changing in this pattern. So where are we actually changing it? And get top keys, okay, that's fine. We're supposed to change it then. And we're not changing it at any other point. NR. Yeah, we're not changing it anywhere else. We are initializing it to 0 here. That seems fine to me. Stats NR. .6 line stats +1 KD dash line stats NR. So I guess someone is writing to it. It's being written to at some other like line. And this is actually the very first. Oh, so now it's no longer going through the list, right? It's no longer going through that entire like more than 3/4 of the array anymore. It's now just stopping on the first iteration. But if I comment out the printf, then it gets farther. So at some point we are just writing to the wrong spot. Where's line stats? Where are we initializing line stats at? Oh, we're not initializing it? Oh, well, we are KD-line stats. All right, yeah, it's because line stats is null at this point, so that's correct. Line stats is null, and so we're subtracting a value from it, so it's going to turn out to be a giant negative number. Then we and this is actually causing a problem. This is causing a crash. That's because line stats is null. Okay, I got it. So if line stats, then we can run this line, and only then. Now let's try again. Okay, so 10.6, it gets to 10.6 and it prints out 0. This means the cutoff is, okay, cutoff is null for that one. So cutoff is apparently not being set for which item? The very last one. The very last item has an invalid cutoff character. So the last line, it has the wrong has a null cutoff, and this is in this is where we specify it manually, right? So read user cutoff here. So that's 0. Cutoff kanji count. So I guess something is wrong around here. So the number of cutoff kanji the user specifies is equal to the number of lines minus 1. But here, yeah, we're not actually getting to every single one. I think what we need to do is just do minus equal 1 here. String contained. No. That didn't work. So cutoff kanji count I is line stats. That seems like it should have worked. Now it's causing a seg fault. Cutoff kanji count. Because the first one is hard-coded, which we set here. And the next, we look for that character in this array in the kanji database. And if we don't find it, then we give an error. If it's not a cutoff type, then we also give an error. Oh. I guess it's because we have to set it here, don't we? Line stats I cutoff kanji count equals cutoff. Okay. And this looks like awful code, but it should be fine, kind of. So when this is equal to, yeah, I think this is how we want to do it. Cutoff, line stats, cutoff kanji count. Dot cutoff. All right. Okay, it's not seg faulting anymore. Very good. It's actually getting to the end. Okay. And now it's going to be kind of hard to figure out if this is correct output or not. No, it's not, because this is way off. The cumulative offset should not be that much. And it's only wrong for the last 2 lines, which is interesting. Okay, so maybe we should kind of clean up the code a little bit, and then maybe the error will become rather obvious once the code is cleaner. So I don't think we want to do this anymore. We probably want to move this down here, right, like it was before. And this should indeed be cutoff kanji count. Replace this with 1. Um, 0. Okay. So we go I is for the array index, but we actually write it into line stats plus 1, because line stats 0 is that hard-coded value. Okay. And now I think what we would like to do is actually set the first cutoff character outside of this function. So KD line stats, so we're going to say first kanji in radical, so right. Cutoff. So this can actually be, okay, this can be over here. This does not have to be outside the loop anymore, right? And now we're going to find where this is. We're going to actually set it here. So kd-line stats 0 equals that. 0 dot cutoff. Dot cutoff. So we don't need it down here anymore. And we also don't really need this as a separate function. Cutoff. Okay. But maybe it's nice to have it as a separate function because we do want to signal a bug if it's not found. And cutoff is kind of a... I also like the fact that there's a temporary variable here that we don't have to spell out so long. So, let's just keep this as a separate function. That's fine. Then read user cutoff kanji. So I think this is going to be fine now. Let's make sure this still doesn't segfault. Okay, good. Okay, and I don't think these print checkpoints are important anymore. Okay, let's just try that again. Right. Okay, so I wonder, oh look, so that's interesting. This line only has one character in it. That's obviously wrong. And that is probably the cause of why everything is so off kilter after it, because this line only has one character, and it still is a correct character. I believe it still is wanted in that line. Can I find it? This means high, or like tall. I mean, like as a measurement, it means high, not like high as in the other meanings for high. So let's look for it in the, oops. I have to use the system clipboard for this. Paste it. Okay, so now it's in the wrong line. It used to be down here. Now it's in the previous line. But the cutoff points are the same. So the last two lines are wrong. So what is going on? The last two lines are wrong. So maybe this line stats maybe this is the wrong termination condition. No, it should be correct. Line stats not equal to that. Say line stats plus 1. So sort key. We sorted line stats. That's char rank. Yeah, this is kind of weird. This is a surprising looking bug. I don't really see why it is, because it doesn't even look like I'm messing up the end of the loop. It's more like I'm messing up the start of it. So actually, just how different are these lines? So we have ame, rain. So it's in the last line in this wrong output. But in the right output, it's in the second to last line here. And Yuki is here. And in the wrong output, it's sorted by radical, so I should be able to find it. It's it's not here. I don't see it here. Yeah, because this is probably a really bad, Yeah, it's only here. Okay. So some of them are not actually there anymore. This is atsumeru, it means gather, and I see it down here in the last line in the wrong output, and it's here in the right line in the second to last output. And here is hanareru, which means take, separate from, or hanasu. And so this is in the last line here and the second to last line here. That's interesting. Line stats. So, yeah, how can we fix this? Resorted I dash ranking KD dash target rank. So, end line. So we end the line, and perhaps we're not ending the line properly. End a line here. End a line. So I wonder if maybe the initialization phase is screwed up. Like this is where we're looping through the kanji database and we're assigning characters into the right slots or into the right lines as we approach them. But maybe the problem is actually more in this area. Maybe it's somewhere around here. So what test is failing? It is last typical kukiri kanji test. And so the screw up could be around in this area. Line stats. Line stats. So line stats is being set here. And end line is done here, and incrementing line stats. It's going to the next line. And print stats summary. So line stats is going to be equal to the very last line stats available at this point. Once we're down here, and line stats. So when it's at the second to last one, it seems like it's finishing right away. It's like it's calling end line right away, which is obviously wrong. So so let's look at a list of radicals first. So GitHub slash oh, we have a list of radicals, right? We have it in the repository doc radical order. So I'm going to try and see if there's anything, maybe this is actually correct, right? Maybe this is the correct output, and I'm just trying to prove to myself that it is correct or incorrect. So so this radical is going to be right, where is it? Should be up here. Here it is. Then kaze should be down, obviously down here somewhere. Here. So according to this output, the characters between these two radicals are only one. That's obviously not correct. So is it even a correct kanji? Because that itself is a radical. Oh, okay. This is interesting. So it's not even in the right position, right? This one is its own radical, and it comes after kaze, doesn't it? Yeah, it comes after kaze. The takai comes after kaze, and yet it's, according to this, it's before the cutoff point of kaze. So that is wrong. So it seems to be capturing all the wrong characters. It's very wrong. And before it did not capture, so takai was in the second line here, which is correct. Okay, last rank contained. Well, that is very interesting. Line stats nr minus 1. So are we setting this to the right value? Perhaps this is not getting set to the right value. Get top keys. Line stats nr plus plus. So this line stats nr is being set to the correct value apparently. I mean, because there's the correct number of lines in the output. End line. End line. So here's line. Oh wait, yeah, this seems interesting. So I guess line stats maybe not. Endline is thinking of the wrong value for line stats. So line stats is being printed here after we increment it, which is correct. That's correct. Okay, but I bet endline thinks that line stats is like a different line than it really is. Line stats. Let's go to the endline function. S. So sorting all the characters in that line. S. And then it's printing them out. Then it's cumulative offset. Now if it's not the first one, then it increases the cumulative offset. But it at least includes the current line offset of the current line. And then here it is printing out last char rank, offset to target, and cumulative offset. That all seems correct to me. Show line. So I wonder if this is correct. Probably it's not. I wonder if e-nr is correct. So we could try it. Sort last rank contained. Okay, so this does not look correct. Now if we do dash, how do I turn this flag on again? N, dash N. So N, this is correct. It's like only 1. Setting it to just 1. Kanji printf. Kanji count. Okay. So total rank s dash. This is just very surprising to me that it is wrong in this manner. Line stats dash keys character. Huh. Cut off. So how about when we end the line, we actually print out like what the index is of the current line stats. Let's see if that's what we expect it to be. So LD, and this is S minus KD dash line stats. So 0 to 32, that means 33 lines. Now, there are 40 characters, and so that means there are 7, 40 minus 33 means there are 7 that are just not assigned to kanji, which is correct. So it's ending each line in succession, end line. So end line, line stats. Okay. So here, let's say that we're adding a character. Line stats dash E and R. All right, let's try again. Character 40. Then, so here we're just adding one character and it's done. And that would seem to indicate that this is true and this is true. Line stats strat, so sort key is less than resorted. Rat so sort key. Cut off. Okay, so all right, so yeah, it's not that one of these are true. It's not that one of these 3 conditions are true. It's actually that it's getting to the end of the entire kanji database. I think. I think that might be what's going on, and so it is line stats. Adding character. Not available. So available could be wrong. Else. Available. Perhaps that has something to do with it. So, in this second to last line, I'm guessing that it's adding, say it's adding character, but it never gets to any not available lines. So it looks like it just kind of gets the end of resorted NR right away. So it starts a new line, it starts the second to last line, and then it succeeds in adding a single character. But then it goes down here, and I is already at the limit of resorted NR. Right? So f print f. So let's print out resorted NR and I. not in that order. And so this is where it's running, it's finishing the last line. And adding character here. And it's already adding character, so it starts one line, adds a character, and really resorted NR is just already at the, it already switches to the very next character. Line stats NR red, so sort key listening, resorted I. +1. So maybe the very last cutoff value is incorrect. Cutoff +1. That's probably what's going on. When cutoff kanji count is 1. Cutoff line stats I+1 dot cutoff. I+1. Yeah, that seems correct. Let's print out the kanji that it is actually on. So resorted I-C. Resorted is the kanji entries, right? Oh, maybe this is screwed up. First key, then rank. I bet it is. First key. I think this is where the problem is. So min is 0, max is 1. So it's trying to find the right first key. And so it's probably, so yeah, what I'm thinking is that when it's sorting the characters first according to the key that they should be under, it's not using it's not like allowing it to pick the very last item. So mid equals min plus max divided by 2. Yeah, this is where it's very easy to make a round off by 1 error, because you're doing a binary search, but it's like by different mechanism. So maybe we can think of an example where we have two keys, like 2 slots, right? And here is the character for 1 at that cutoff point, and the character for I don't know, right? Let's do something simpler, like that's day or sun. And then maybe we'll do why is it like that? Why is that character there? I don't know why that character is considered, why that character has that code. Anyway, here we'll do home. So 1, day, and book or source. So we're going to start with min is 0 and max is 1. Line stats dash nr minus 1. And if that's inclusive max, then that's correct. So there are 2 different keys, and so min is 0 and max equals 1. And so then it's going to look at, it needs to look out at the cutoff point. Oh, in this example, I guess it's not correct, right? This example, okay. So we only have two cutoff points to worry about. And one of them is like hard-coded, the first one. So this means that there are two lines, and so line stats nr minus 1 is 1. Okay, so 1 plus 0, min plus max, is 1 divided by 2, that's 0. So it's going to check 0. And here we say if line stats is 0, oh, but that's always going to be 1. So we never want to actually check 0, right? Because that's always going to be less. This is always going to be true. So this must be wrong. So let's say we do this, mid plus 1. Mid plus 1. This is if we do this, then we're going to get this cutoff point. And if it is less than the Radso sort key that we're looking for, then that means that min is equal to mid plus 1, which is correct. Otherwise, the max is equal to mid, which is 0, which is correct. And then min, so as the example, let's say that the character is in here, right? So we're checking this, and this is going, if this is less, so we're checking this key for this character, and if this is less, so it's not, it's going to be false, because the hypothetical character is in this range. So it's going to be false. So max equals mid, which is 0. So min and max are the same at this point, and so we're going to return min, and that's correct. It's 0. Now if the character is in this range, then this is going to be true, and yeah, because the cutoff point is here, so we're going to min equals mid plus 1, right? And so that means min equals 1 and max equals 1, and so we return 1, which is correct. And now if it is equal to this character, then it's the same deal. So this may have fixed it, or maybe it just kind of removed two errors that counteract each other. Okay, let's see what happened. It didn't look very good. So first key, min plus max. So this might be an off by 1 error, possibly. Use mid. So let's say we have one more character here to actually make this, so we can check here. Alright, so now we have 3 ranges and 3 cutoff kanji, one of them being hard-coded. And let's say, so in that case, min starts out at 0 and max starts out at line stats nr. So there's 1, 2, 3. So max is going to be start at 2, right? And so that means mid is going to equal 1, and so that means we're going to check line stats mid plus 1. So we're going to check this because it's going to be 2, 0, 1, 2. So we're going to check this cutoff character, and this cutoff character, it's fine to check that. So let's say the character is in this range, and we're checking this cutoff character. So this is going to be, oh no, hold on a second, 1 plus 1. 1, yeah, we're checking 2 here, because this is equal to 2. So 0 and 2, so this is going to be true. So min equals mid, which is 1, is 2. Min is 2, max is 2, and we're done. Now let's say the character's in this range. So this is going to evaluate to false, and that means max equals mid, which
which is 1, so we get 0 and 1 here. Min is 0 and max is 1. And at that point, I think that it's fine. We're just kind of gonna we've already checked this possible scenario, right? We've already checked this, so that's fine. 0 and 1. So this is going to mean that this is equal to 0 plus 1 equals 1. Okay. So just how wrong is this anyway? 1260, 1279, 1 minus 1. Now the problem actually is this wrong or is this more right? Because this does not look very wrong, this output down here. It doesn't actually look all that wrong. Not obviously. And so I wonder, what is a test that failed? Last rank contained to automatically find kukiri. So this is when it's automatically finding cutoff characters, which is an interesting problem. But Kurti 0. So it goes right from 0 to key. Okay, so it's not every line that's wrong. What? Expected last rank container. Maybe this is definitely wrong. Dot test out. Right. So 1, 2, 3, 4, 5. Yeah, this doesn't look all that wrong. 0 and Q. Because what was the difference? The difference started at 0, which is like the 10th key. The other keys were not even registering as wrong until this point. And so I wonder what changed. Why did it start getting different at this point? That's very interesting. Wow. Okay. Yeah, this is a hard problem, isn't it? Now I gotta figure out if it's even if this is the wrong output or not. And I don't see anything wrong with the diff. I mean, the diff is going to take a long time to look at. Maybe not want to worry about that right now. First key. I wonder, are the cutoff points different? Yeah, the cutoff points are different. The automatically found cutoff points are different. 1279, 4 and 3. I mean, maybe, do we want to run this? Rank contain dash n dash quiet? Or what was it? Dash h for no kanji, dash k for no kanji. Excuse me. ASDF the end. I'm still printing out ASDF the end. Let's remove that. SDF. Grep. Where am I printing out ASDF? I don't know. Last string contained. Printing out a whole lot of junk. A whole lot of debugging junk. Hmm. So, hmm. I guess what we could do is we could try and feed the automatically found kanji back to it. Feed the previously found automatically found kanji. So there are two steps, right? There's finding the cutoff point automatically, and um, there is printing out the characters in the range based on the cutoff points. So either one of those two could have changed, right? So to narrow it down, we can actually take the expected output. Let's see, expected output, and use this to actually like feed the feed it back as arguments, and then we see if this is actually changed. If we see what part of the behavior is changed, because now we're going to remove one variable, which is the actual finding of characters. Expected auto find, right? Oops. Okay. Now we want to say grab dash. We want to skip the last four. Head n plus 4. Does that work? No. -4. Ah, that did work. Okay, good. And is that the right number of lines? 33. Okay. So we take this and we give it as xargs to dot new sort last rank contained 0. We want to skip the first one, or tail dash n plus 1 plus 2, I think. Terminated by signal 11. ASDF. Okay, interesting. So it's not printing out the last two lines, apparently. Okay, so something's still wrong, quite wrong, because this is terminating with signal 11, which I guess is not really a signal exactly. It's more like the exit code. I believe I saw an 11 somewhere. So we want to say grep w11 star.c star.h and contain test kanji db. Check kanji database order. That doesn't seem right. Terminated by signal 11. What is signal 11? Signal. I guess man 7 signal. Signal 11 is segmentation fault, invalid memory reference. Okay. So now this is interesting because this means we want to keep this as a test. So I'm going to save this in like add a test for this, right? Because that is like crashing very violently, and we don't like that. So let's do add a test for this. Oops. Let's make this into a script for now. Edit, add a test for this. And this will be bash bin bash, right, that as new sort last rank contained. All right. Add a test for this. Add a test for this. Seg fault. Okay. Line 3. Okay, very good. We're making good progress, I suppose. But we're still not really running that many tests. A test for this. Let's fix this problem. Oh, it's no longer crashing. So now let's see out and diff temp out and expected auto find exit 0. Okay, so it seems like maybe the automatic that would suggest that the process of automatically finding the kanji is screwed up, or it's changed since last time. But we're also getting a seg fault, which is not good. Um, hmm. So now we've kind of lost our lead, so to speak. Automatically find cookie. So this is no longer working properly, is it? Cut off kanji count. Count not available. Target rank. Rank coverage reset. Line stats cutoff equals. Find best cutoff. So perhaps this function is no longer doing what it needs to, because I'm trying to like look at what could have gone wrong, and I think what's gone wrong is probably how we've handled the line stats line, like this thing right here, this array. That's the thing that's most likely gone bad. Maybe this just needs to be -1. Available. Because we're starting that's the line we're starting. Could have conch. Let's try it. Automatically find. No. Although I do like that change. That change does make sense. Line stats dash cutoff. So we're basically saying this is how many characters that we need in this line, right? And rank coverage reset. Because rank coverage reset is a mechanism where we kind of go over the kanji database in the radical stroke count sort order, and then it incrementally tries to find out what the right cutoff point is, because essentially as you're adding kanji to this from the sort, like the rank coverage, which is like the rank of the least of the highest numerically ranked kanji, or the least used, will essentially get smaller and smaller as you add more characters. And so it'll start out as a very large number, and then it's eventually going to get to like 0 and then go negative. And so the idea is you want to stop and pick the cutoff point as soon as, like right after it starts getting negative, and after you've already found the value that's closest to 0. So that's a very brief explanation of it. And available cutoff kanji count. Line stats. It sets the cutoff of the next line, which seems correct. It uses the available count of the previous line. Cutoff kanji count. It doesn't use the available count of it never uses the available count of the last line, which I suppose is correct. But anyway, how close was this? Did this get any closer to being correct? Hide kanji. Oh, so hide kanji is the one that failed. Automatically find kugiri, hide kanji. Automatically find kugiri is actually now, kugiri means cutoff. This is now passing, so that's actually good. And so the one that's wrong, it looks like the hide kanji is just not working correctly. Automatically find kugiri test. Hide kanji. So it looks like hide kanji. The problem with it is that um, it's including this count at the end when it shouldn't. So I need to wrap this line because this is actually, we're getting closer. It's starting to look pretty good. Now, it seems like the only problem here is that we have failed to properly interpret this flag, and it is show per line kanji count, which is wrong. Show per line kanji count is 1. Seems like it's just always showing it. Dot 40. Oh, okay. Because we have to reset it. We basically have to reset it for the test. But I don't really like doing that, do I? Kanji distribution. Can we just include this in kanji distribution? No, I guess it doesn't make sense to. That would automatically reset it to 0. But great, so it's actually passing. And I don't think we want added test for this because I don't actually think that was what was causing the seg fault. So let's, because once we rebuilt it, it was like working. So let's just forget about that. And here, now we're gonna want to make sure that this looks good. So this was quite an involved task, and but so we're gonna want to call it a night, and let's just go over this really quickly and see where we are. So we've created line stats and kanji distribution. Kanji distribution has every line in it at like in complete form. It doesn't store the lines like temporarily. It just has all of them all at once, and that should be fine. So just let me double check the fields here. ENR. I don't know if ENR is needed. ENR is that really important? ENR. QSort and line. So ENR, we don't want to reset. We don't want to reset this to all to 0. That's not needed anymore. We don't want to reset the lines to 0 because, like I just said, we're keeping them. So NR plus plus, adding values to it. NR end line, end line. I guess we can just keep ENR. It feels a little bit like extra, but we can still keep it. Let me make sure this still builds and passes now that we've deleted those lines. Okay. Now I'm gonna just skim this very quickly and make sure I don't have any lines that are greater than 80 columns wide. Because all right, it looks fine. I need to save it. Let me try again. I didn't save it for the test. Okay. So assign short total rank, total characters, target rank. Now let me make sure the other fields in this line stats thing are being treated properly. Cumulative offset, cumulative offset, cutoff cumulative offset. Okay. Find best cutoff. Okay. It's funny. Passing that around as a pointer. So cumulative offset equals 0. Oh, are we even setting this? We're setting it in here in end line. Cumulative offset. Okay. So maybe we don't need to keep this as a separate value here. So cumulative offset. Find this cutoff. Yeah, this doesn't it seems like this extra value is not needed. Offset. So yeah, because we're basically calculating the cumulative offset here. Then we're doing it again in end line, which feels dumb. So I think we can just say like kd dash line stats cutoff kanji count nice dot cumulative. Oh, but then it's tricky because how are we going to get the very last line here? So cumulative offset, oh, for the first line is 0, isn't it? No, it's just equal to the target offset. Yeah, I guess we'll just leave it as it is. Or maybe I'll put it to do. Oh, I won't even do that. It's getting late. So kanji distribution in okay. Offset to target. Offset to target. Target. Okay, that looks fine. Subtracting here, adding here. Okay. And then line stats. Okay, so are all the fields used properly? Available, key ch, last char rank. First key for codes in this line. Yeah, I don't like the way this is a sparse. Like, well, this is dense. I think it could be sparse. So like the keys that don't have a the codes for where the first when a key is not used as the first key of any kanji code, then we're not even having a line stats for it. But I think we could have a line stats for it and just make it empty, and that would be a little bit easier. And then we wouldn't need this line stats nr thing hanging around, which is just awkward. So that looks fine. We fixed that sorting function, which was the cause of so many problems. Top key, we just inlined that. Oh, we deleted all of these things. Hide kanji. So get top keys. This thing was simplified. It looks like kr. No longer doing that. So we are setting the line to line stats nr++. Okay, setting the key character, setting available, and setting total characters. So let's see, s dash. The line looks very long, but it's fine. Okay, it's not too long. Total characters plus equals unused kanji key count. Use kk index. Okay. So hide kanji. End line overall. Okay, end line. And I feel like this has changed so much that I don't even want to read this. I don't even want to read the diff. I just kind of want to skim the changed code here, and that's easier for me. So hide kanji. We're printing it there, of course. And cumulative offset. Calculating cumulative offset, which we probably don't really need anymore. And then printing out the end of the line. Total rank plus equals last char rank. Okay. Print stat summary. Can this just be inlined? It really ought to be, I think. This print stat summary is no longer buying anything. Print stats summary. So it used to take the line stats thing, and I think it like used a shorter shorter name for line stats, and maybe that's why I liked using it. But now it just seems a little unnecessary. But this is probably going to change a lot when we actually refactor out when we finally get the kanji distribution struct into a separate module. So let's just leave it as at that. Okay, print stats summary. So where were we? And find best cutoff. That function did not change, I believe. And is better cutoff. That did not change. Read user cutoff kanji. So this looks pretty good. Line stats plus one dot cutoff. Okay, is better cutoff. Then end line. End line. Okay. End line. Seems fine. I think we already checked that anyway. Find best cutoff. That's fine. And then, oops. Print last rank contained parse args. This is really the main function where everything is called and jumped to. Resorted. Strings. Qsort. Resorted. Okay, line stats equals resort cutoff. Saying the cutoff, that's if we're doing the cutoff automatically. And down here we're going to the next line stats, and that looks fine, I suppose. Line stats. Okay. Okay, I think I'm ready to commit all this, and that was really quite an adventure. It was a bit hectic and arduous, but it's done. We kind of, so what do we actually get done? We refactor line stats, so each line is stored separately and at once, right? Call layout summary, and yeah, call the new container kanji distribution. All right, this prepares to turn it into, what are we preparing to do? To move kanji distribution generation logic to a separate module. Okay. All right. And so, yeah, we cleaned up some macros, and that was the easy part. Then we made sure we kind of cleaned up the romazi module so that the mapping didn't have any extra junk in it. We removed the dash from the key index to the character ASCII value mapping, because that's not needed for kanji input. And then we refactored line stats, and that took the bulk of the time. And that's it. I think we will stop for today, and I'm gonna have to take a break. Thanks for watching.
Okay, I was interrupted, but this should be fine. So we are here, we are calculating line stats, and let's change this to ls because we already have some lines we have to wrap. So line stats, cumulative offset, okay. Okay, let's see if this works. Okay, good. So that was fine, and we have calculate cumulative offset there. So we're getting closer to pulling the printing logic out of the loop. And so what we want to do, I guess, is put this printf down here. right? And end the line, and then print the stats summary. And we don't need to end the line up here anymore. Line stats dash available. Okay. Offset, end line. And we can say, instead of end line, we can call it print line stats, and move this out. End line. Okay. And then this prints the start of the line, this right here, and print line stats. Do we still need KD? Yes, we do, I guess. Oh, we're still calculating total rank right here. So that's not good. So we want to calculate total rank elsewhere. I don't see any other lines calculating values here. Line stats S. So we could change this to, we also have to change the name of this. S. Okay. Total rank. Alright, so we want to do this over here when we end the line. KD total rank. Alright. Let's try this. Make. No. One of them was wrong. Here. This is just printing out the very last line. Okay, yeah, so KD dash line stats I. And we don't need brackets here. Print stats summary. Cumulative offset. Okay, now here, this is a bit awkward because we're doing an OR here, and yet the two like paths are completely different, right? So I think that we don't need to set initialize line stats to null. We can actually do set line stats outside. So let's initialize line stats here, right? Line stats. We don't need to set it to null explicitly anymore because we don't really care about that case. And yes. Okay, we don't need these two lines or this. And we no longer care about this. Okay. Oops. Now we have too many parentheses we don't need. Okay. That looks pretty good. Let's try that. Print line stats. Okay. Okay, this is not right. This is the average rank of each line. So this is not right. It's changed. And I'm guessing it's because we did this here. Probably because we didn't add it. Yeah, calculate cumulative offset. We probably want to do this here. That way we're doing it for the last line as well as the non-last lines. So let's call this end line. line, because we're now not calculating only the cumulative offset. End line. And okay, looks like we fit on one line. That's good. And okay, let's make this line stats 231. Yep, this has to be non-const. Okay, good. Now this is looking kind of awkward. I don't know if I like that we were calling end line twice. Maybe we need to move this at the end of the for loop, and then we don't have to actually call it like we don't have to call it outside of the loop anymore. No, that's not going to work because this is these two conditions are never going to be true when we're even when we're ending the last line. They're not going to be true when we're ending the last line under any case, under any circumstances, because we don't have a cutoff for the very last line, or we don't have a cutoff for the end of the last line. So do we need this check here? If that's never going to be true, make sure that we're not at the last line. End line, line stats, line stats. Well, we are checking the next cutoff, the next line, so I guess we need it. Yeah, this does look a little awkward, but at least it's not. It's been there since before we started this work, so maybe that's fine. Okay. Okay, so now it looks like we've finished that. We've actually made the print stuff separate. End line, print line stats. Oh, do we still need this for loop? Yeah, we do. But we don't need it outside. We can put it inside, I guess. I want to keep the diff clean. I'm not going to change that. How many lines are in this file now? 347. It's not even that many lines. I guess it's not doing a whole lot of stuff. So make it again. So now we're going to say remove printing logic to outside of calculating logic. And I'll make a better commit message later. And then I'll put that over here. Oops, didn't work. Alright, so actually we added one more task which I didn't think I would do for this video. And okay, that is good. And so now I think is the end of the video. And thank you for watching.